College Algebra 2, Lesson 3, Graphs and Functional Values. Here we have the function f of x is equal to x squared. It's called a quadratic because it's x squared. To see what the graph looks like, we have a table to the right. When x is 0, 0 squared is 0. That's the y. When x is 1, 1 squared is 1. When x is negative 1, we also get 1 because the negative squared is a positive. When x is 2, we get 4. When x is negative 2, we also get 4. When x is a half squared is a half times a half. You multiply the tops, you multiply the bottoms, you get 1/4, and the same would be true if we put in minus a half, we would also get 1/4. Here we have the graph of the information. And we'll note that the red curve is symmetric about the y-axis, and we call this a parabola. If we had extended it, if we were to do x is equal to 3, we would have to go up to 9, and the graph stops at 6, so we just stop it there. So most people call it a parabola, but I'm going to call it a cup, and the cup is infinite. It goes on forever. And the reason for call it a cup, when we get to things like x to the 4th, x to the 6th, x to the 8th, or leading terms of polynomials are those, we'll always get a cup-shaped figure. Here we have f of x is equal to x minus 1 squared. It's another square. It's going to be a cup. Now, it's this simple. You don't have to do another table. You simply ask yourself, what makes the quantity x minus 1, what value for x makes it 0? 1. So simply start at x equal 1, and then you go over 1, you go up 1, you go over 2, you go up to 4, a height of 4. If you go to the left 1, you go up 1, and if you go to the left 2, you go up to 4. It's that simple. It's called a linear transformation. All we have to do is figure out what makes the thing in the square 0, and it's 1, and that's where we start. We start actually at the point x is 1 and y is 0. Now to plot this one, we have 2 times x squared, but still x squared, so we're going to get a cup or a parabola. And so we do it mentally. When x is 0, we get 0. When x is 1, we normally go up 1, but now we got 2 times that, so we go up 2. And when x is 2, we're going to go 2 times 2 squared is 8, so we're doubling what we went up before, and that works on the right hand and the left hand side. So the 2 makes the curve go up faster. Here we have f of x is x squared minus 3. It's another parabola or cup. And we say, where do we start? Well, what makes x squared 0? What value of x? 0. But the y value is x squared minus 3, so we've got to go down 3 steps. So we're starting on the y-axis at negative 3. And then relative to that dot, if you go over 1, left or right, you go up 1. If you go over 2, left or right, you go up 4. If we went over 3 steps, left or right, we would go up 9. Now we have f of x is x minus 4 squared. That's the squared part plus 2. Where do we start? So the first question is, we're going to move it left or right. What makes x minus 4 squared 0 when x is 4? And then once you get there, if you put in 4, you go add 2, so we go up 2, so we're starting at the point 4, 2. And then relative to that dot, if you go over 1, left or right, you go up 1. If you go over 2, you go up 4, and so forth. Here we have f of x is equal to minus the square, x minus 3 squared. What's the effect of the negative? It is simply to flip the curve upside down. So how would we see this? Suppose we say we put in for x 4. That's sliding over 1 step from the 3. Now, if you put in 4 for x, you'll have 4 minus 3, that's 1 squared, but now it's minus 1. So at 4, we go down 1. So it's the same as saying if you go 1 step over, instead of going up 1, we go down 1. And the same would be to the left. If you go over 1, you go down 1 if you go left. And then if we go over 2, left or right, we go down 4. So the negative sign, all it does is have the curve go down instead of going up. Here we have the absolute value function. What is absolute value? When you put a number in, say the absolute value of 5 is the positive part of 5, which is 5, and the absolute value of negative 5 is the positive part of negative 5, which is 5. So absolute value of negative 5 is 5. This is relatively a simple function relative to x squared because, as you see in the table to the right, if x is 0, y is 0. If x is 1 or negative 1, we get 1. If x is 2 or negative 2, it's 2. If x is a half, you get a half. And it's not beveled at the bottom like x squared was. It's a straight line on the right and a straight line on the left. And you could think of this as the graph is the letter V. And so if we were to do other ones with the absolute value of x, we could have the absolute value of x plus 2. You would start 2 steps up. Or if you had the absolute value of x minus 7, where do you start? What makes the absolute value of x minus 7 0? 7. So you go over 7 steps, and then you would proceed. Go over 1, go up 1. Go over 2, go up 2. Go to the left. 1, 2, 3. Go up 1, 2, 3, and so forth. So you just do the same thing over and over as we did with x squared. And if you put a negative in front of the absolute value of x, then the v would be going down. Here we have the square root function. Now, f of x is the square root of x. If we look at our table to the right, the square root of 0 is 0. 0 times 0 is 0. So what do you square to get 0? 0. Now the square root of 1. What's the positive number that you square to get 1? 1. 1 times 1 is 1. It is true that negative 1 times negative 1 is 1. But the square root of x is defined to be the positive number that you square to get 1, so it's 1. Now we try to do the square root of negative 1. Is there a real number that you can multiply by itself and get negative 1? No. A positive real number times a positive real number is positive, and a negative real number times a negative real number is a positive real number. You're never going to get negative 1, and the square root of negative 1 is defined to be I. And that's a complex number. You cannot plot it on the xy axis. X, left and right, those are real numbers, and the y's, up and down, those are real numbers. You cannot plot I. The square root of 4, we know that to be 2. 2 times 2 is 4. Why don't I have the square root of 2? Well, that's approximately 1.4, so it's a decimal number, and I'm just trying to get some integers so it's easy to plot. The square root of 9 is 3, and the graph only goes to 5, so we won't use that. But we do have to know what happens between 0 and 1. If we take the square root of 1/4, that's the square root of 1 over the square root of 4, and that's 1 over 2. So it's beveled up. And we see the blue curve represents the square root of x. Now, this square root of x, that has a domain. All real numbers greater than or equal to 0. And the range, the lowest value is 0, and it goes to infinity also. Here we have f of x is equal to the square root of x minus 1. First thing we got to do, we got to be sure that x minus 1 is positive or 0. So the domain over to the right, x minus 1 must be greater than or equal to 0. If you move the negative 1 over to the other side, simply change the sign. So x is greater than or equal to 1. And then we go back to the same way we did it with the square root of x. The square root of 0 is 0. So we start at 1, the value is 0. If we go over 1 unit, we go up 1. If we go over 4 units, that's at 5, we go up to 2. And if we go over a fourth of a unit, we go up to a half. So it's the same picture, but we're just starting at a different point on the x-axis. Here we have f of x is equal to the square root of x plus 3 minus 2. Now we have to have x plus 3 greater than or equal to 0. So we see on the right hand side the domain, and if you move the 3 to the other side, you simply change the sign. So x must be greater than or equal to negative 3. So we slide over 3 from the origin, 0, 0. And now the function says that we got to go down 2 steps. So we're going to start at the point negative 3, comma, negative 2. And then we do the same routine. If we go up 1 over 1, we go up 1. And if we go over 4, we go up 2. If we go over 9, we go up to 3. It's actually off the graph. And that's what our function looks like. And they're negative values for this function. But all the values for the square root of x plus 3 are either 0 or positive. It's the negative 2, which gives us some negative values for the functional values. In this example, f of x is equal to the square root of 2 minus x. Now, in order to do this, 2 minus x must be greater than or equal to 0. So you can't put in, say, 3. That would be 2 minus 3 is negative 1. And the square root of negative 1 is I. You can't plot it. So over on the right, the domain, 2 minus x must be greater than or equal to 0. If you move the 2 over, on the right-hand side, it's negative 2. So now we got minus x is greater than or equal to minus 2. The simplest way is to multiply both sides by negative 1. When you multiply by a negative, you must change the sign of the inequality. And so now x is less than or equal to 2. So we plot some points. If x is 2, then you got the square root of 2 minus 2. That's the square root of 0 is 0. And now we could put in 1 for x. The square root of 2 minus 1, the square root of 1 is 1. We're going left. And if we put in 0, the square root of 2 minus 0, that's the square root of 2. That's approximately 1.4. And we could put in negative 2. So 2 minus a negative 2 is 4. The square root of 4 is 2. So we see the curve actually goes to the left. And this has to do with the argument. It's not x minus 2, it's 2 minus x. And we've got to be sure that 2 minus x is either positive or 0 in order to graph it. Here we have the reciprocal function. F of x is 1 over x. Now, we cannot plug in 0. 1 over 0 is a meaningless term. So that's excluded from the domain, but all other x's will work. So if we have 1 over 1 is 1, 1 over 2 is a half, going down. 1 over 3 is 1/3, going down. 1 over 10, 1/10. And you look at the right-hand side of the graph, it's getting very close to the x-axis, but it's never going to touch it. So if you took 1 over 1,000,000, that's 1/1,000,000. It's still not at 0. And if we look at the other side, on going up, and if we put in a half, so what's 1 over 1/2? It's 1 over 1 divided by 1/2. Outies over innies would give you 2. And you could also say 1 divided by a half. How many halves does it take to be 1? It's 2. And you could do 1 over 1/10, do outies over innies, or you could say 1 divided by 1/10. How many tenths does it take to be 1 is 10. But it also works on the left-hand side of the graph. If we put in negative 1, 1 over negative 1 is negative 1. And then we could put in minus 1/2. 1 divided by minus 1/2 is a negative 1 over 1/2, which is 2, so it's negative 2. And you could do 1 over negative 1/10. It's a negative. 1 over 1/10 is 10, so it's negative 10. So the curve is going down, getting close to the y-axis, but it will never touch it. And if we go out the other way, if we do 1 over negative 5, that's minus 1/5. And then we could do 1 over negative 10, that's 1 over negative 10, a minus 1/10. It's getting close to the y-axis, but it's never going to touch it. And if we look at the curve, it's have symmetry about the origin, and this is called the reciprocal function. Here we have two functions, exponential function, logarithmic function. They're kind of opposite to one another. We'll do the exponential function first. So f of x is equal to 2 to the x. So if we do 2 to the 0, that's defined to be 1. So we have a dot at 0, 1. What's 2 to the first? That's 2 times itself one time. That's 2. So when x is 1, we have a dot at 2. Suppose x is 2. Well, 2 squared is 4. Suppose x is 3. 2 cubed, that's 8. So we see the curve going up. And if we went out to 10, it'd be 2 times 2 times 2, 10 times. And 2 to the 5th is 32. And 32 times 32. So we have to give that a little thought. If we did tuples, you'd have a 9. And then we'd have a 4. And then you do crisscross, that would be 12, and the 1 goes over, and that's 1024. That's using tuples mentally. Okay, now it goes up really fast. Now let's go on the other side. Suppose we raise 2 to the negative 1 power. You can't multiply 2 times itself negative 1 times. It's defined to be 1 over 2. That's a half. And then we could do, what's 2 to the negative 8th power? That's 1 over 2 to the 8th. So that's getting to be a rather small number, but we're not touching the y-axis. And then we could say, what's 2 to the negative 1 million? It's 1 over 2 to the million. It's a huge number on the denominator, but it's not 0. So that curve gets very close to the y-axis, but it's never going to touch it. Now, we look on the other function, the logarithmic function. It's the opposite of what we're doing. So we're doing the log base 2 of x. And so we'll do a simple example. We'll put 8 in. And the log 2 base 2 of 8 is defined to be, what power do you raise 2 to get 8? 3. So if you look at the red graph, we have a dot at the point 8, 3. That's the power that you raise 2 to get 8. What's the log of 4 base 2? Well, 2 squared is 4. So when x is 4, y is 2. And then we keep going. What power do you raise 2 to get 2? That would be 1. So when x is 2, you go up to 1. And we can keep going. What power do you raise 2 to get 1? Well, that's 0. 2 to the 0 is defined to be 1. And then we could keep going. The log base 2 of a half. What power do you raise 2 to get a half? That would be negative 1. So 2 to the negative 1 is 1 over 2 to the first, which is 1/2. And if we could keep going, and we could say, how do you get the log of 1/8? Well, 2 to what power would give you 1/8? We could do 2 to the negative 3, that's 1 over 2 cubed, and that's 1 over 8. So we can see we're going down very fast to get 1 over a fraction, and it's 2 to a negative power that goes down. So we're not going to touch the y-axis, but we're going to get very close to it. Now, if we look at the blue curve and the red curve, and it seems like you could flip them over and land on one another, but not across the x-axis, not across the y-axis, not across the origin, but across the line y is equal to x. And because of this, we say the exponential function and the logarithmic functions evaluate functions. We'll start off with f of x is equal to minus x squared. The laws of exponents tell us to do x squared first, then do the negative. So, with that in hand, if x is 0, y is minus whatever 0 squared is, which is 0, so it's minus 0, which is 0. Put in 1. 1 squared is 1. The answer is minus 1. Put in 2. 2 squared is 4. Minus 4. Put in negative 2 for x. Negative 2 squared is 4. Minus 4 is our answer. Put in negative 3. Negative 3 squared is 9. The answer is minus 9. Put in a half. A half times a half. You multiply the tops, you multiply the bottoms. That's 1 over 4, but it's minus 1/4 is the answer. Now, a lot of folks will say that minus 3 squared is 9. That is incorrect. If I did minus 3 quantity squared, that would be 9. But where does everything go wrong? And here's the rather disturbing fact. If you put minus 3 hat 2 in Excel, it will tell you it's 9. And we won't just stop at Excel. You could go to numbers in the Apple computer system. They will also tell you it's 9. Some of your phones will tell you it's 9, but if you Google it, it will come out minus 9. So it's the laws of exponents. You do x squared first, then you take the negative of that, and that's why all the answers are negative. Evaluate functions. So this one, f of x is the absolute value of x minus 3. And you might look in the table. I have in red the minus signs. All we're going to do is evaluate the absolute value of x. We'll put x in, and then we'll see what we got. So the absolute value of 0, 1, 2, negative 2, negative 3, and a half is respectively 0, 1, 2, 2, 3, a half. It's the positive parts of all the numbers. Now we're going to put in x. So we got 0, 1, 2, a negative 2, a negative 3, and a half. And then we're going to see what the expressions give us. So when x is 0, 0 minus 0 is 0. Minus 3 is a negative 3 for y. Put in 1. 1 minus 1 is 0. Minus the 3 is negative 3. Put in 2. 2 minus 2, minus 3. The 2 minus 2 is 0. Negative 3 again. In fact, you could put any positive number in, and I think you would realize that the answer is always going to be negative 3. Now, when we put the negatives in, we got 2 minus a minus. That's a positive 2, so that's 2 plus 2 is 4 minus 3 is 1. And then we have 3 minus a minus 3, that's 3 plus 3, that's 6 minus 3 is 3. And we're back to the positives. A half minus a half is 0, and we take away 3, and we got negative 3 again for an answer. So this is a rather easy way of doing functions when you're trying to evaluate them. Put your signs in like pluses and minuses, evaluate whatever it is with x, and then just calculate the quantity that remains. It's a much simpler way than trying to do the absolute value of x, and you take away x, and you take away 3, and then you get your answer. It's much easier to set them up so the negative sign is stuck there. We got 2 negative signs, and you just put your numbers in for whatever it is with x, and then you can work the problem out. I think it's a much easier way. Now, here we have f of x is minus 1 to the x power plus 2 to the x power. It seems like it would be hard, but we'll just go through it. So when x is 0, and I got the plus sign in red, we will have minus 1 to the 0. Anything to the 0 power except 0 is 1. So you can't do 0 to the 0, meaningless term. But any real number to the 0 power is 1. Okay, plus 2 to the 0, that's also 1. So 1 plus 1 is 2. Now we're going to raise each thing to the first power. Minus 1 to the first is minus 1, and 2 to the first is 2. Any number to the first is whatever it is, and minus 1 plus 2 is 1. Now we're going to do squares. So minus 1 squared, well, negative 1 squared is 1, and 2 squared is 4, so 1 plus 4 is 5. That's easy. Now we do negative 2. So minus 1 to the negative 2 is 1 over minus 1 squared, and minus 1 squared is 1, so that's 1 over 1 is 1. And then got 2 to the negative 2, that's 1 over 2 squared, and that's 1 over 4, so we got 1 plus a fourth, which we write that as 1 and a fourth. Okay, now we're going to raise everything to the negative 3 power. So minus 1 to the negative 3 is 1 over negative 1 to the third, which is negative 1 over negative 1, because negative 1 cubed is negative 1. So that's a negative 1, and plus 2 to the negative 3. That's 1 over 2 cubed, and that's 1 over 2 plus times 1 over 2 times 1 over 2. That's 1 over 8. So we got -1 plus 1/8. And that is minus 7/8. All sorts of ways of getting it. We can think of 1 as 8/8. So we got minus 8/8, and we're adding 1/8, so you got 7 left, but it's minus, so it's minus 7/8. Next one's a little tricky. When you raise numbers to the half power, that's essentially the square root. If you raise a number to the 1/3 power, that's the cube root. So these are square roots. So -1 to the half power. What's the square root of -1? By definition, that is I. Okay, plus, now we got 2 to the 1/2. That's the square root of 2. What do you multiply by itself to get 2? Approximately 1.414. That's why you got that little equal sign with that little dot above it. So our answer is I plus 1.414. Most people would write it as 1.414 plus I. And that's evaluating, so we have to know something about exponents, and we're able to do the table relatively easy manner. Evaluate functions. We start with two functions, f and g, and we define 4 new functions, and it's relatively simple. The sum function, we see on the right, f plus g of x, is defined to be f of x plus g of x. That's the value at x. The difference function, f minus g, that's what it's called, of x, is defined to be f of x minus g of x. The product function, you see f circle g, that's like a high-tech times of x. That's defined to be f of x times g of x. And the quotient function, f over g of x, is defined to be f of x over g of x. Now, some folks would tell you to combine f and g with the x's. The difference with the x's, the product with the x's, the quotient with the x's. However, you're just doing yourself a lot of work over nothing, because if I had f of x to be like a 10th degree polynomial and g of x is a 5th degree polynomial, like x to the 5th, and you're told to divide it, why would you do that? You could evaluate f for a value, evaluate g for the same value, put them together, you could add them, subtract them, multiply and divide them. So there's no sense to have to combine all the x's and all that stuff. That's just a lot of work over nothing. So in the table below, let's say we want to know what f plus g of 4 is. F minus g of 7. F times g of 2. F over g, the quotient function of 1. Let's work out the individual values for 4, 7, 2, and 1. So for 4, x is 4. We'll plug the 4 into 2x minus 5. So 2 times 4 is 8 minus 5 is 3. And now we go down to 7. 2 times 7 is 14 minus 5. That's 9. We put a 2 in. 2 times 2 is 4 minus 5 is a -1. And you put a 1 in. 2 times 1 is 2 minus 5 is -3. Now let's work them out for g of x. So we got x squared plus 3. So we plug in 4. 4 squared is 16 plus 3 is 19. We plug in 7. 7 squared is 49 plus 3 is 52. We plug in 2. 2 squared is 4 plus 3 is 7. And we plug in 1. 1 squared is 1 plus 3 is 4. And now let's do f plus g of 4. Well, 3 plus 19 is 22. That's simple enough. And what's f minus g of 7? The two values are 9 minus the 52. And that's -43. F times g of 2. -1 times 7 is -7. And the quotient function of 1 is -3 over -4, the fraction, but I've written it as -3/4. So this is a much simpler way of evaluating functions. And let's say we didn't have just 4 little values, 4, 7, 2, and 1. Say we had 500 values that we wanted to calculate f plus g, f minus g, f times g, and f over g. You would set it up in a spreadsheet. You'd calculate f for all those values, calculate g, and then you could perform those operations in a spreadsheet, because a spreadsheet knows how to add 2 numbers, subtract 2 numbers, multiply 2 numbers, and take the quotient of 2 numbers. So a much simpler way of doing things.